Hey everyone, and welcome. Today, we're going to vibe code something really cool. A simple, real-time multiplayer drawing app that runs right on your desktop. We'll be using Electron to create the desktop application, Vite for a super-fast front-end experience, and a lightweight server framework called Hono to handle the multiplayer logic. Ready? Let's get started. First things first, let's create our project. I'm in my terminal, and I'll use the Vite TypeScript starter template. I'll name our project Splash App and use the TypeScript template. This gives us a great starting point with all the basic Electron structure set up for us. A main process, a preload script, and our renderer code. Alright, with the project open, our first step is to build the backend. We'll use Hono, a small and incredibly fast web framework. Let's install it by prompting Gemini. It created the core of our app, a simple 20 by 22 dimensional array, and filled it with zeros. A zero will represent an offer blank cell. Gemini will also need to create our first API endpoint, a GET endpoint called /view. When a client hits this endpoint, we'll simply return our grid as a JSON object. Super simple. Now, inside the src directory, I'll create a new file called server.ts. This is where our server logic will live. Inside server.ts, we'll move all Hono-related code. Now we need to make our Electron app actually run this server. Let's open src/main.ts. We'll import our Hono app and tell it to start listening on a port, right after the Electron app window is created. With our server ready to serve up the grid, let's switch to the front end. Open up index.html. It's pretty bare bones right now. I'll clean it up and add two things: a button with the ID server_connect and a div with the ID grid where our drawing board will go. Now for the logic. Let's open src/renderer.ts. We'll prompt Gemini. When the button is clicked, we want to fetch the grid from our server. It will make a fetch request to the /view endpoint. If it's successful, it gets the JSON data and passes it to a new function called renderGrid. The renderGrid function will take the grid data, clear the container, and then loop through every row and every cell, creating a new div for each one. We'll append each div to our grid container. Let's start the app and see what happens. Okay, we click Connect, and nothing happens. But wait, if we open the developer tools, we see a CORS error. What's CORS? It stands for Cross-Origin Resource Sharing. It's a security feature that stops a website or app from making requests to a different domain than the one it came from. In our case, the renderer and the main process are treated as different origins. Luckily, Hono makes this incredibly easy to fix. Back in our server.ts file, we'll ask Gemini to fix our cores error. It will import the cores middleware from Hono/cores and tells our app to use it. Just one line of code, app.use, cores, . Let's restart the app. Now when we click Connect, our grid appears. It's just JSON output of the earlier grid, but it's being dynamically generated from our server's data. Seeing JSON output is fine, but we want to draw. First, let's give our grid some style. Let's ask Gemini to style our grid. It will change the CSS file and use CSS grid to style our container, and give the cells a border so we can see them clearly. It will also include logic to parse the incoming JSON and change the background color. For now, this will only render gray, as our backend still only sends a grid of zeros to our renderer. Next, let's make it so we can change a cell's color. This requires a new server endpoint. In server.ts, we'll create a put endpoint at /draw. This endpoint will expect a request body containing the x and y coordinates of the cell to change, and the new color. For safety, we'll add some validation to make sure the coordinates are within our grid's bounds. If they are, we'll update the grid array at that position with the new color value. Now, back in the renderer. In our renderGrid function, when we create each cell div, we'll also add a click listener to it. When a cell is clicked, this listener will trigger a fetch request to our new put/draw endpoint, sending that cell's coordinates and a color. Let's run it. I'll open one window and click Connect. Now I can click on cells and they turn green. But here's the magic. Let's open a second window. I'll connect the second client, and it instantly shows what was drawn on the first one. Now, if I draw in the second window, the changes appear immediately in the first, and if I draw in the first, they appear in the second. We have real-time, multiplayer drawing. And there you have it. In just a few minutes, we've built a fully functional multiplayer desktop app using Gemini, Electron, and Hono. We set up a server, rendered a grid, handled cores, and implemented real-time updates. Thanks for watching, and happy coding!